Hello everyone, very good afternoon all of you. Welcome to Unified Study. All are ready for the marathon, computer architecture marathon. In this class, from basic to advanced, digital logic, new number system, after that computer architecture, memory organization, programming, cache, mapping, DMA, everything, pipeline also, everything we are going to cover in this class. So those who are new to this channel, definitely subscribe to the channel, click the bell icon to get all latest update notification and to stay tuned with us and prepare yourself for your exam. Because here you are going to get this crisp and quality content because we are following less is more. After doing this class, your total computer architecture revision will be done. So all are ready? So one like to banta hai. This everything I am going to complete here in this class. Those who are live now, just be ready with your pen and paper to solve the questions and to take the important notes. I can see who are live here. Yes. I hope my audio, video, everything clear. A very good afternoon. If you want to really join, then join. Those who want to join our course, you can visit our website. This is our website, unifiedstudy.com. You can visit our website. You can come to the paid course. Here the paid course is available. But now for the exam season, this is going on. That is for only few days subscription is going on. This is 15 month and this is 15 days and this is 10 days subscription. After 26th, here long term subscription will be available for 6 months. You can go for it. Okay. Those who are interested, you can go for it. Chalo. Here I can see Vijay, Priyam, Aparna, Reena, Jayashree, Pushpa, Devi, Rajita, Sandhya. Okay, chalo. Let's start. First question. Little bit your warm up. We will do the warm up. 3 months, 6 months, everything will be available after 26th. From 27th onwards, you will get all the options. 3 months, 6 months, 1 year, each and every option will be available. Warm up session for number system. Number system is also coming. Your computer architecture means unit 2. Number system is there, digital logic is there, computer architecture is there. So yes, easy question. This is super easy. Where you have to find out the 4 and 5, what is the base of the y, how to find out base of the y. You have to take the highest one, highest number is 5. So y should be greater than of 5. That trick you have to apply. So it cannot be 5. It can be 6, it can be 7, it can be 8. So definitely B is the correct answer. Now tell me. Do this one. I'll be not able to talk, unnecessary talk I will not do, okay, because too much cough and my throat condition is very bad. I'm taking hot water, all that. So I will not do any unnecessary talking. Please do it. Wherever required explanation, we will do. Yes. So here you have to think it is allowable length for integer, means positive, negative both, means signed and unsigned both you have to think. That's why for the this one is also coming, this one is also coming, because you have to think about signed, unsigned both. Now you see. Now here again another question, same type of question. At least value of signed and the unsigned. Least value. Yes, here B not. Those who are telling B, they are wrong. Option 4 is the correct answer. For the sign, whenever you are going for 8 bit, it will be 8 bit means sign means 1 bit is eliminated because of the bit. So whenever you are taking the last bit, that MSB is dedicated for doing the sign plus or minus. So I have 7 bit. That's why 2 to the power 7 means I can get minus 128. Minus 128, then 0, then 127. This is the range. Range will be minus 128 to plus 127. Very carefully remember that. And for the unsigned, it will be 0 to what? It will start from 0 to what? Tell me. 2 to the power 8 means 256. Then the range will be 0 to what? What will be the last? Tell me. For the unsigned, it is asking you least. I am telling you the maximum number. What is possible in unsigned one? Maximum. Let me know in the comment section quickly. Next one, octal equivalent to the hexadecimal. Yes, very good, Jayashree. I am getting answer from Jayashree. Very good. Now tell me, octal equivalent to this number. Good. Himalatha. Good. Swarna, you are wrong. Kaliraj also wrong. What is the answer for this one? Yeah. So here, whenever there is fraction, then you have to go this side and you have to go this side. For D dot C, D means what? It is given that hexadecimal number. Hexadecimal number A means 10, B means 11, C means 12, D means 13. 13 how to do? 1, 2, 4, 8. So 1, 8 plus 4, 12, then 1, 13. So 1101. You are getting here 1101. Now you have to see that it is point C. C means what? C means 12. C means 12 means this is 1100. So I am going to write 1100. Now in this direction I have to split it in 3 group. So 3 group means here I have to add 2 zeros. So I am getting here this is 001, this one. So it is 1 then 5. And here I have to go this direction, that is this one, then 2 zeros. So it is what? It is 6. 6 then 0. So it is actually 15.60 means you can write it, okay, 15.6. So answer is this one. Maximum students will do mistake here. You have to go in this direction, then you have to go in this direction. Hexadecimal means 4-bit representation. After that make the grouping of 3-bit. Right? Yeah. Next question. This is also very important. Complement. What will be the complement of this Boolean function? And the same question you have to do what will be the dual. For this same question you have to do what will be the dual. Complement and dual. Very, very important. Difference between complement and dual. Good afternoon, Lakshmikant. Yeah, here answer is coming. Here whenever I am doing complement, complement means always remember I have to add not. Complement means what? Not. Whatever x you are doing x bar. So it is f means I have to do f bar. I am doing here complement. After applying the De Morgan's law, as per De Morgan's law we know that x plus y whole bar we can write it x bar dot y bar, or x dot y whole bar I can write as x bar plus y bar. This is as per De Morgan's law. So when you can see this term and this term is same term, so I can do this same, and this one is same. So ultimately I am getting this one. After doing the complement according to De Morgan's law, I can write it this way, that a bar b whole bar, then c d bar whole bar, then a bar b whole bar, again I can write a plus b whole bar, because it is what, a bar bar plus b bar. Now a double bar means a plus b bar, then cd whole bar means again c bar plus d bar. So final answer you are getting here, a plus b bar dot c bar plus d. This is your answer by doing complement. Now tell me what will be the dual for this. If it is the complement, then what is the dual? Dual and complement, most confusing. Most of the time students are doing mistake here in dual and complement. Even also you have to tell me the dual and complement for a plus 1. Tell me the dual for a plus 1 and the complement of a plus 1 or a plus 0. Quick. Because we have to do so many questions. There is no time to wait. I am going here. Here, whenever I am doing dual, yeah, option is not there. Where you are getting option? Option was not there. So dual means first though definitely this one and this one coming same. So whenever I am getting the original one, this is coming a bar b plus c d bar. Now dual, remember that dual is not changing the variable. Variable will be same. For the dual, no change in variable. Only it is changing or to and to or, and 0 to 1. No change in variable. And that's why your dual will come here. You can see that a bar b plus c d. This is the dual. Okay. Here just go through the difference between complement and dual, which is very important. Most of the time students are doing mistake in complement and dual. Nowadays it is very popular. They are asking question again and again. In complement we are doing a complement, but in dual we are not doing it. Dual and will be changed to or will be changed to and, 0 will be changed to 1. Here we are doing a bar, but it will be same. Here a will be as it is a, no change. Just like that, if I am taking this example, a plus 0 complement, then it will come a bar dot 1. But whenever I am doing dual, a plus 0, then we are getting a dot 1. A dot 1, because a will be as it is, plus will be changed to dot, 0 will be changed to 1. That is the difference between dual and complement. Very important difference. Must remember that. Here high chance you can do the most mistake. Okay. Unified Study app free mock test. Research aptitude is mock test not available. Computer science mock test is available. For paper 1 I am not handling. Actually paper 1 Tulasi ma'am is handling. So maybe Tulasi ma'am can reply you. I am handling computer science. Tulasi ma'am is handling paper 1. I will inform Tulasi ma'am. Now the next important topic is K-map. That is most important topic of K-map. Do the answer. Sequence of K-map. Quick. Yes. The sequence of K-map, those who are telling 3, this is wrong. 3 is not the correct answer. Here first you have to draw the K-map. You are doing mistake, identify the group. Before identifying the group, you have to transfer the truth table. After truth table transfer then only you can identify, because I am drawing that. After that I have to put the 1 and 0, right? That is important. So that's why this is your answer. Don't do mistake here. Here you are getting confused with this. So now do some questions so that ultimately the sequence should be clear to you. This is an easy question on K-map. Tell me the answer quickly. You will also do. I will also do with you. So do it quickly. here ABC is there. So we have to take like this way. This is A, this is BC, 0 1 0 0 0 1 1 0 1 1, 0 1 2 3 4 5 6 7. This is most important at the time of writing, that here is 1 then 2 then 3. This is most important at the time of doing this. Now you see here summation, this is 0 1 3 and 7. It is there. Now what will be the answer? I have to do the grouping. Whenever I am doing the grouping will be always 2 to the power n. Means group of 2, group of 4, group of 8, group of 6 is not possible, because it is not coming under 2 to the power, right? So now final answer, what answer you will get here? How to get the answer? How we will get the answer here? 1 1 3 0 1 3 7. Yes, all of you are giving answer option 3 is the correct answer. How it is coming? How this is coming? You can make the grouping here. This one is easy grouping, and here this 2 is left. So I can do this 2 left, right? So whenever I am doing grouping here, it is what? It is actually BC. This one is BC. 1 1 means this is BC. 1 1, that is BC. Now from here I am able to cancel 0 and 1, and from here I am getting 0. This 0 means it is A bar, and from here I am getting 0 means it is B bar. So I am getting A bar B bar plus BC. That is my answer. Now again another K-map. Nowadays they are asking very simple K-map. So do it quickly. It is also with 3 variables. This is also with 3 variables. You have to draw quickly and then you have to answer. See that here this is the summation given, and this is don't care condition. Don't care means I can take D here. So the don't care condition is helpful when you are doing the grouping. Then you can include don't care to make a larger group. That is, to make a larger group you can use the don't care. So where I can use the don't care, I can take this one as a larger group. Now unnecessary don't take this one. That is not important. Now to make the larger group here again, I can make this one. Yes. So if I am making this one, am I getting this answer? A bar plus BC bar. Because why? All BC cancel means this is A bar. And here this is what? This is coming, that A cancel, but it is BC bar. From here I am getting BC bar. So answer is A bar plus BC bar. This is your answer. Right? A bar plus BC bar. This is not fourth one. Sorry. A bar, right? It is A bar. A bar means this one. A bar plus BC bar. Yes. Another K-map. Quickly do it. This is 4 variable. This is another one, 4 variable. Quickly do that so that your all practice will be done. Then we will move to the next topic. Each and every topic I will try to cover, which is most important topic. Then here 0, 2, 5, 7, 8, 10, 13 and 15. Yes. Yes. Now you have to think that in middle this all 4 you can make it as a group, and all the corner you can do the corner folding. This corner folding is possible. Always at the time of K-map you have to think about folding, corner folding, side folding, top folding. All these foldings are very important. So whenever you are doing the folding, you are getting this answer. Option 1. How you are getting this answer? Because here, from here you are able to see that 0 1 cancel, means from here I am getting D, and from here this 0 and this 1 is cancel, means from here I am getting B. So BD. Now from here this 0 and this 1 is cancel, means from this corner I am getting here D bar, and from here this 0 and this 1 cancel, means you are getting here A bar. So that's why your answer 0 B bar. B bar. You are getting here B bar. 0 is there, so you are getting here B bar. So B bar D bar plus BD. That is your answer. BD plus B bar D bar. Option 1 is coming. Right. Now next, move to the next topic, that is memory. Most important topic of computer architecture. Every time you are getting question in paper 1, paper 2 both. This is not only for paper 1, paper 2, paper 1 both. Different types of memory organization, primary memory, secondary memory, the sequence, everything. So quickly do the brainstorming of this type of question so that you should not do mistake in this area. 100% sure you will get question either in paper 1 and paper 2 both, or at least out of 150 questions, some question will be there in this topic, and where mostly students are doing mistake. So please don't do the mistake. That's why we will do these all types of question what they ask in this area. Do it quickly. First question. Yes. Here very important to read the question very carefully. Incorrect, false. These are the trap of the examiner. Always I am telling. False. Which one is false here you need to find out. The processor has direct access both primary and secondary memory. Here is CPU. CPU is directly connected with primary memory. That means it is your RAM. Okay. Then after that here it is coming secondary memory. Okay. Secondary memory means your hard disk. Your hard disk is your secondary memory. So in the primary memory it is directly connected. It is not connected with secondary memory. That's why this is false. Primary memory store the active instruction, because whenever you are running any program, it is run in primary memory. That is correct. That is correct one. Here secondary memory used for backup. Yes, we are storing whatever data you are storing. D drive, C drive you are using. Those are your backup memory. Memory system implemented on a single memory level, not it is always in multi-memory level. That level question is here. Here you are getting those levels in how it is divided. So that's why this one and this one is false, A and D. Now let's move to the, yes, don't see false. That's why if you are ignoring the false, you will answer here B and C. And you will get 0 out of 2. Anda milega anda. Okay? Be careful about that false. Which one is false? If you are thinking, okay, तो true ही बोलता है, तो चलो B and C कर दो, तो बस गया काम से. ठीक है? Yes. Here this is a very common mistake. Most of the time students doing mistake in this question. Most of the time. I don't know why. Most of the time students are giving answer as cache memory. They are telling that cache memory is the fastest memory. It is a blunder mistake, common mistake. Cache is not the fastest one. Always remember register is the fastest one. Register first, then cache, then main memory, then secondary memory, then come to external memory. According to speed. And sometimes students questions are asking according to speed, according to cost, according to size. Okay, here size is increasing and here speed is decreasing in this direction. If the question according to speed, then register is the highest speed. If it is asking according to the storage, then external memory is the highest storage. So don't do mistake that cache is the highest memory, not highest speed memory is register. So that's why register is the answer. I saw every time 50% of the students doing mistake with that cache memory. Please don't do that. I don't want to listen, ma'am, I did mistake. I don't want to listen that. Now see that again, another question. These are the very common question of memory. Okay, increasing order, and read the order what they are asking. Increasing order, decreasing order, low to high, high to low, speed or capacity, what they are asking. That is very important. That is very important. Yes. Here the option 4 is the correct answer. Here it is asking increasing order respect to the access time. Here see that. It is according to access time. Access time means here very careful. Why this is, why it is coming that access time and it is coming increasing order. Increasing order means low to high. Low to high. Okay. Now access time, when your speed is high. Speed high means access low. Access time low. Because if your car speed is 60 km per hour, to go 24 km you need 4 hours. Right? Just remember that 60 km per hour when my speed, then to go 24 km I need 4 hours. If my speed is 40 km per hour, then to go 24 km I need 6 hours. So whenever speed is high, access time is low. So the register, here the register speed is high. That's why access time is low. That's why it is here. That's why this is here. And the optical disc, here speed is low. That's why access time is more. That's why it is here. Okay. Low to high and access time. Very careful about this question. Maximum time students are doing mistake here. Don't do that mistake. Now see here again another question here. Fastest to slowest. I can see you are very happy by looking. Okay, very thank you. I am getting so many hearts. Thank you. Yes. Now tell me, quickly do it. Yeah. Here again, it is DRAM and SRAM, static RAM and dynamic RAM. Here it is register, and again here it is magnetic tape and hard disk. Here you will be confused. So static RAM, here I am telling you the difference, and first do this question, after that I am telling you. Do all the mind mapping we will do. Quickly do this one. Quickly do this one, then we will do the mind mapping of this topic. L1 cache, L2 cache, L3 cache, main memory, hard disk, SSD. How they are combining each and everything. Do it. Yes. Here answer is option D. Here also you will do mistake. L1, L2, L3. Remember that. Here. This chart will be very much helpful for doing this type of question. You can see so many questions on this topic. They are asking like this type of question, right? You can see these questions. So that's why this chart is very helpful chart. Register is the fastest one. Then SRAM. SRAM is the static RAM. Static RAM you are using for the purpose of cache. It is cache purpose. That's why it is static RAM. Static RAM, another way you can remember, it is cache actually. Then dynamic RAM. Dynamic RAM, that is DRAM. DRAM is actually the main memory. DRAM is actually main memory. Then SSD. SSD means nowadays we are using solid hard drive, right? So it is the fast secondary memory. It is secondary memory, but it is the fastest one. And HDD, hard disks. Whenever we are doing the normal hard disks, HDD, it is speed is lower than SSD. Then optical disc. Optical disc means like CD, DVD, Blu-ray. These are slower than HDD also. Then magnetic tape. Magnetic tape is very slow and sequential access. Okay. So that's why fastest to slowest whenever you are going, that is register, then SRAM, then DRAM, because SRAM is the cache. Another way you can remember, this is cache and this is main memory, right? And SSD, here also you can remember that SSD, after that HDD, hard disks, then optical, then magnetic disks. And whenever you are going for level of the cache, then L1 is the highest level, 1 is the highest one, L1 is the highest, then L2, then L3, then L4, then main memory. Remember, this chart is most important, from where you are getting maximum question. These all the questions just now whatever we did, this all question was from this topic only. So write down it, remember it, don't do mistake. 100% you are getting one question always. For computer science student, it is a common topic, right? Yes. Now tell me, which is main memory? Then just now I tell you, which is main memory? Yes, external. Yes, Jayashree, CD, DVD, those are external. Yes. Here, which one is main memory here? It is asking you which one is main memory. So RAM is the main memory and cache memory is also the main memory, because cache memory is your SRAM. Just now I told you cache memory is SRAM and normal RAM means you can think like that DRAM, right? So these both are main memory. Yes. Now here the comparison between SRAM and DRAM. Here the topic, comparison between SRAM and DRAM. Yes, here you can see the difference between SRAM and DRAM. SRAM, static RAM, we are using for cache. DRAM we are using for main memory. So SRAM is faster compared to DRAM, because SRAM is not refreshing unit. You are not refreshing the SRAM, but DRAM you are refreshing. Okay, and it is expensive one. SRAM is low density, DRAM is high density. So that's why here you can see the answer of SRAM and DRAM, which one is the correct. Here you can see the answer that the slower than static RAM. Here it is asking which one is true about DRAM. So DRAM is slower than static RAM, this is correct. The package density is higher than the static RAM, this is also correct. It is faster than static RAM, no, because static RAM is faster. By eliminating C also you can do the answer, but D is there. So A, B, D all are correct and it's required refresh. So all this thing, it came from this chart. You can remember this chart and you can take the screenshot also, the difference between SRAM and DRAM, which is most important. You are getting question from here, right? Yes. Now tell me, an address in main memory called what? It is also most common confusion of the student. Address of the main memory called what? Yes. Address of the main memory is always physical memory. This is physical memory. We did that. It is the concept of paging. Logical memory, logical address to physical address conversion is going on. So main memory is physical memory. Very good. Now tell me then, what is virtual memory? What is virtual memory? Read question very carefully, then do the answer. The Gautam Kumar, I think you are paid learner. Yesterday you was asking, right? Gautam Kumar, are you paid learner? You was asking something yesterday's class about subscription. Yeah. So here again be careful about that. It is asking you which one is not true. Very important. Which one is not true here? Okay, most of you are giving answer option 1 and you are getting anda. Anda milega anda. Everyone is getting anda here. Suji, Jayasri, everyone is telling that it is correct. One is correct. Why? It is asking you which one is not true. Here read it. The virtual memory storage, the memory management is the technique that provide idealization abstraction. It is abstraction. Okay, it is not at all the physical one. It is completely virtually it is giving you the concept. Okay, so our abstraction it is creating resource actually available given in the machine, which creates a illusion. What illusion it is taking? Because in my main memory maybe the space is available 2 MB space, okay, but I need to execute a program. That program required maybe 8 MB space, but it is creating that illusion that yes, you are able to execute that 8 MB program. How? By creating the virtual memory concept. Virtual memory use the both hardware and software to enable the computer compensate with the physical memory storage, temporarily transferring data to the random memory, that is RAM, to the disk storage. Sum of the part like 2 MB I can give you, remaining 6 MB I will store in the hard disk. It will store in the hard disk, and one by one by doing swapping I will take some of the part, I will execute. After that I will again take the next one and I will execute, so that it will create a illusion that everyone is getting chance and completely my program is running, but not in a one time. Not in a one time. This is a concept of virtualization, that is virtual memory. Why you all are telling option 1 is correct answer? The main objective of using virtual memory is increase the effective capacity of the memory system. It is not, it is creating the illusion, increasing effective capacity, not, because it is capacity is not at all increasing. Capacity not at all increasing. It is increasing the showing that yes, I am able to run the program. Right? So the size of the can be larger than the secondary memory. This is also wrong. This is also wrong. So none of this is correct. Okay, and it is asking you which one is not true. Be careful about that. Any one is not true. None of this is not true. Why? Now you will see that. Here you will think that which one is, now you will be little bit confused. Ma'am, you are telling what? Here it is true. Actually here you are thinking this is also true, this is also true, this is also true. It is asking you which one is not true. So any of these are not false. Any of these are not false. Everyone is true. Everyone is true here. Everyone is true here. It is asking which one is not true. Everyone is true here. So the main objective of using the virtual memory is to increase the effective capacity of the memory system. This is also true, because effective capacity, by making the virtualization, it is making the effective capacity. That's why this is true. Size of the program can be larger than the size of the secondary memory. This is also true. The program of the data stored in the secondary memory, this is also true. So none of these are false. None of these are not true. Got it? That's why none of this is answer. These type of questions are very confusing, where 99% students are doing mistake. By looking the question, maximum students will do mistake. All are true actually. Got it? Clear? All are true. Okay? So how you will be trapped in exam hall, just see that. You will be trapped in exam hall like this. Now here, I am going to the next topic, and before that again there is the virtual memory. Virtual memory is a very important concept. Again and again they are asking question from here. Those who are watching, एक बार like तो कर दो. For doing the like, share and subscribe. No one is asking you money. So at least your like will give us motivation. Okay. If you like, if you little bit comment after the class, if you put some feedback, if you invest your 1 minute time, 1 second time for that, then actually we are making free content, we are getting some motivation, nothing else. Your like is not giving us money. Your like is giving us motivation. Okay? So please do that. Yes, the address translation is performed by every logical address, and during the execution of program, that is, which one is here, see that this is correct, this is incorrect, this is incorrect, this is correct. So here this statement 1 is actually true, this is correct, because the address translation every logical address, this is true. Now the program can execute only when all the components are loaded into the memory. This is wrong. Because total part you are not loading at a time. Some of the part you are loading, you are executing, after the remaining part you are loading. That's why this is false. So statement 1 is true, statement 2 is false here. Okay? Okay. Now, PDF will be for the paid learners. Everything it's not available free of cost. I am sorry for that. I am investing my too much effort for these things. So everything I can't make it free. If you need to learn, you can watch the complete class. That will be good. Interface that provide I/O transfer data directly and from the memory unit peripheral. Which one is the correct answer? Yes. So here input output processor and direct DMA. Most of you will do mistake here with option A. Most of you, 90% students will do mistake with this one, option 1. But not only option 1, here A and B both are the correct answer. Because why? Input output processor, it is a special type of processor. You can read this one. Maybe it is hiding behind me, you can read this. The DMA mode is the data transfer CPU, where directly it is bypassing the CPU to connect between the input output, right? Direct access memory. An input output processor or IO channel, another name. It is a special type of, just like the CPU, that has, it is just like the CPU, but that has the detail of the IO operation. Just like the CPU, but it has the detail operation, right? So that's why the input output channel is also doing the same work, just like DMA controller, just like that. Here it is more equipped with the facilities those available typical DMA, because input output processor can fetch and execute own instruction that specifically designed for the characterization of IO structure, IO transfer. So it is a special type of input output processor. That's why here option A and B both are true, not only DMA. These both are true. Now here you can see this is the input output processor, and here it is the difference between serial interface and parallel interface, which one was there in your question. So you can go through it. Now see, the next question is here. The next question, The register that hold the address of the effective memory. Quickly do the answer. We have to do so many things. Don't do delay. Quick, give me the answer. Yes. Here, next address. It is asking you active memory location and the next address. That is MAR and program counter. MAR, memory address register, and the program counter. Both are holding. Right. Now next question. Hard disk as a part of the computer memory. The mechanism that uses the hard disk as a part of the computer memory. Which one? Yes, it is virtual memory. Virtual memory is the memory management technique that use the operating system to extend the available RAM using the disk space, and it's create a illusion to the large continuous memory, allowing to operate more memory from the physically available. So it is virtual memory. What is overlaying? Then what is overlaying? Yes, overlaying is also allowing the large problem than the computer main memory but required more effort. Why? Then what is the difference between looking like same, virtual memory, and overlaying looking like same? Then what is the difference? Both are memory management technique, but in the case of overlay, whole system main memory management is done by the programmer. But in the case of paging, operating system has responsible to do the managing memory. So overlays are managed by the user while virtual memory managed by the operating system. Concept are same, but one is managed by operating system, another is managed by the user. That is the main difference. Remember that. Then we are coming to the next topic, that is instruction cycle. Most important topic. Next topic, you started the journey of computer architecture. Now we will see one by one, we will move to the next topic. One by one I am moving to the topic. Here now next topic you can see instruction cycle, which is most important. Again and again repeated question came from here. Sequence. Yes. Here option B is the correct answer. Yes. Yes, 20 days. 10 days option is now there. 10 days option is there. 20 days option I take it. You can go for, if you want that, you can go for rank booster. Rank booster course will be helpful for you for your DL. Rank booster available in 499 rupees. 15 days subscription available, where you will get the all PDF and the test series. The test series will be very much helpful those who are preparing for DL, because here you will get the all subject wise test series, full length test series. So many test series are there, and the live classes recording of PYQs and MCQs are there, and the PDF also you can, it is visible in the app. You will be not able to download, but PDF are available in the app. You can view it for 15 days. You can access this, all these things. 499 rupees rank booster, it will be good for you. Yeah, so here you can see that again another question. First we are fetch the instruction. After fetch, then decode, right? Then it is reading the effective address. Then which one is the next? How to download the hall ticket? You have to go to your login to the UGC NET website. Then you can download the hall ticket from UGC NET website. Which one is the correct sequence? Yes, very good. Option 3 is the correct answer. Fetch is the starting. So this is not the answer, this is not the answer. After fetch, decode. So fetch and decode is done. After decoding, calculate the effective address. Then fetch the operand. Here only you will be confused. A after D or D after A. First you have to calculate the effective address. Then you have to get the operand. That's why this one is the correct answer. Right. Yes. So here you can see the instruction cycle. Fetch, decode, read and execute. At the time of after the decoding, at the time of decoding is required here. You can see another question again from this topic. Special purpose register. What is the task of program counter, ALU? Instruction register is also there. These are very important registers. Yes. Option 1 is the correct answer. So program counter is the register which is always keep track of the memory address the next instruction to be executed. And it is holding the memory address of the next instruction to be executed. The instruction register is the component of this in the CPU which is temporarily store the binary code of an instruction before the control unit decode the execution. It is exactly that instruction it is holding. Okay, so instruction register responsible to ensure that instruction processed and sequence correctly. That's why here you are getting this answer. Program counter keeps track of the next instruction. Instruction register hold the address of the instruction? Not. It is not holding the address of the instruction. Accumulator hold the output. This is correct. Program counter keeps tracks only the first instruction. This is also not. Right. Is it only holding first instruction? Not. It is holding the address of the next instruction. Keep track address of the next instruction. In B it is given the address of the instruction. Address of the instruction not. Current instruction binary code. Whatever instruction you are going to execute, that instruction code itself you are executing. That's why option B is wrong. Got it? Why not B? Is that clear? Maximum students are marking this one. 99% students are doing mistake here and getting 0 out of 2. So it is wrong because of this. Clear? Yes. Now see. Here the sequence of the event happen during the typical fetch operation. Yes, MAR, memory address register holding the address. The question is here. All your doubts will be clear with the questions. I make the question in that sequence only. Yes. Here, first of all, it's required program counter. Why? How the sequence is going on? The sequence is program counter, then MAR, then memory, then MDR, then instruction. How? Because CPU fetch the instruction from the main memory into the register one time. And program counter is always holding the address of the next instruction. So to get the address of the next instruction, you have to come here. After that, the CPU then decode it, execute and repeats until the no more instruction is there. So the correct sequence is fetch, decode, read, then execute. Fetch, decode, read, execute, right? So for that, MAR, memory address register is holding the address, then it is going to the memory. Then from the memory it is fetching the data and it is storing that data into MDR. Okay, clear? So that's why here your MDR not, it is MBR, memory buffer register. Memory buffer register, MBR. Okay, yes. Okay, now do this. Good evening, good afternoon, Nishu. Now do this. Yes. Option 1 is the correct answer. Very good. Just now we did all that. Now no need to explain. I hope still now some students are doing mistake. So now quickly I will tell you about addressing mode, which is most important topic. You can get minimum to maximum 10 marks. 2 to 10 marks highly expected from this topic. Right? These are the different types of addressing mode. Santosh, good evening. So these are the different types of addressing mode. Implied mode means inbuilt in the clear accumulator. Okay, complement accumulator. In the code itself, it is telling you what to do. No need to do any extra operand. That is called implied. So here implied means you can see that implicit addressing mode, right? It is in that one only it is present. Complement accumulator, I know what to do. In the accumulator I have to do the work, so no required of extra operand. Next one is stack addressing mode. Stack addressing is always taking the operand from the top of the stack. So it is also not required, but I am taking it from the top of the stack, like add. So okay, I know that first two operand I have to take it from the top of the stack. That is stack. Immediate. Now most of the time students are doing mistake between immediate and implied. Implied, remember that implied no extra operand is there. The program itself, the operation itself telling you what to do. Not required any operand, not required any data. But whenever you are coming to immediate, the immediate means if I am writing like add 10, this 10 is my data itself. This 10 is my data. It is not my address. That's why it is called immediate. Next one, whenever you are coming to direct, one memory reference is required. So if I am writing here like add 20, I have to go to the location 20. In the location maybe the data is 60. So here my effective address is 20 and my data is 60. That is the direct addressing mode. Indirect means here just like that you are getting direct addressing mode. If I am writing here 20, I am going to this location 20. Now indirect addressing mode, to memory reference. Here I am writing add 20, I am going to this location 20. Here maybe it is 60 written, I have to go to the location 60. Maybe here it is given 100. So my operand value is 100, but my effective address is here 60. That is the difference. Whenever you are coming to the indirect, then these are the symbols of indirect. Register indirect and memory indirect. Two types of indirect is there. Register indirect means if I am writing add R1, means in the R1 I have to go to R1. In the R1 maybe it is written 20, then I have to go to the memory 20. So one register reference, one memory reference. One register reference, one memory reference. But memory indirect means two memory reference. That just now I told you. Two memory reference like this. Okay. Now register direct means directly you are going to register. That is maybe add R. So R is my effective address. R1 may be effective address and here maybe something is written for 40. So 40 is my data, R1 is my effective address here, that is register direct, right? Now register indirect, I already told you, this is register relative. Now here 3 is there, that is relative. Relative means with the operand you are adding the program counter. Operand you are adding program counter value, and program counter is always holding the next address. It is always holding the next address. So that's why program counter plus the address part of the instruction, this is your effective address. ठीक है, ये pointer may be indirect mode. Yes, indirect means it is holding the address, so that's why it is pointer. It can be. So you can see the relative here. I am adding the program counter with this. Index you are getting here, index at register plus instruction, because here same thing, and here the base register, another one is the base register. So 3 more main differences. Here you are adding base register with the address part, here you are adding index register with the address part, here you are adding program counter with the address part. These 3 are doing same work, same type of work, right? Next one you are getting here auto increment. Here very careful, auto increment means effective address will be same, after that it is incremented. So you can think like it is post increment. It is actually post increment. Okay. So after accessing the operand, the content of the register is automatically incremented. That's why it is effective address will be same. The size of the D step of the operand, it will be incremented. Only one memory reference required here. So no extra calculation required for current effective address. ठीक है? Here direct and direct register is same? No. Direct can be memory also. Direct can be memory also, direct register also. Direct means you have to think about memory, and register direct means it is register. Okay, so here is the example of auto increment. You can see my effective address is not changing. My effective address is 3300 and my operand is 6B. But after that it is incremented to 3302. It will be useful for the next operand. For the next operand it will be useful. That is very important. Next one is auto decrement. Whenever you are coming to decrement, then content minus size of the step. But it is pre-decrement. But this is pre-decrement. This is not post. This is pre-decrement. Okay. So you are doing content register step of the size. First content register decremented, then after that access. So that is the difference between auto increment and decrement. I hope it is clear to everyone. Now do the question. Now you can see a question. I hope it is visible. This is very good and important question. Do it quickly. Yes, auto increment like post increment and auto decrement like pre decrement. Exactly. Yeah, answers are coming here. Option 1 is the correct answer. Here you can see the location 500 and 501. So here it is 500. Here this is 501. And you are storing 400 here. And it is opcode. Right. Now R1 contain 200. So R1 containing here 200. It is given to me. Now it is given here direct. Direct means I have to go to that location directly. One memory reference. So my effective address is 400. I have to go to the location 400 to get the data, and it is asking you to calculate effective address. So that's why it is your effective address. Register indirect. Register indirect means where you have to go for two memory reference. So whenever I am doing two memory reference, one register indirect means one register plus one memory reference. Which register? The register is R1. So I have to go to R1 first reference, then I have to go to memory 200. So actually my effective address is 200 here. That's why this is my effective address. Index with R1. So what I told that operand value plus index register. So operand value is 400, index register value is 200. That means my effective address is 600. That's why this is my effective address. Relative means operand value plus program counter. Current program is ending on 501. So program counter will hold the next location 502. Next location is 502. And the operand value is 400. That's why 400 plus 502, 902. That's why your answer is here 902. And this is your answer. Very important, like this way you can get a comprehension type question. I will show you what type of comprehension you can get. So here is a question, auto increment, auto decrement, and this one. Read, think and answer. Yes, definitely option 2 is the correct answer here. Because why? Option 3, only 3 is correct. If auto increment addressing mode include the instruction search, then additional ALU is required, not required. What I told, auto increment is working as post increment. So for effective address calculation, whatever currently there in register, that is only my effective address. For that, no extra calculation required. After doing it, I am doing plus plus for the next operand. That's why it is wrong. Auto increment is self-relocating, not. Self-relocating means here is my program, automatically it is updated. Like whenever you are doing operand value plus base register, right? These are like auto increment is going on. Here self relocation is going on, but here no self relocation. That's why this is also wrong. So option 3 is the correct answer. It is wherever there only it is executing. Okay. Now tell me, what is the answer for this one? Yes, here is the answer. 2 and 3 is the correct answer. Very good. Absolute addressing mode, base address, relative address, and this one, which appropriate program relocation. Just now I told, wherever relocation is going on. I am adding here base register, that's why relocation going on. I am adding here program counter, that's why here relocation going on. Now do this. These are the current trend question. They will give you this type and they will ask you what addressing mode it is. These are current trend. What it is? Yes. Here you are getting that it is the operation L address then X. After equivalent to what we are doing, that in accumulator we are adding address plus XR. Some extra thing we are adding. Whenever we are adding something extra, it is not direct, it is not indirect. Only here I am adding something extra. Here only we are adding that something extra. That something extra is here. That's why this is your answer. Yes. Now tell me. Now you have to match the addressing mode with the instruction. Actual instruction. 8085 instruction. These all are. These are called current trend questions. Answer. So many students are there, those who are watching silently, but you are not answering. What is the meaning? If you are not answering, here some of you are giving option 1, not. Here you have to think direct, indirect, register, immediate. How to understand? Here whenever you are coming to MOV, copy from the source to the destination. The instruction copies the content of the source register into the destination. And MBI, the name I is telling you immediate. Move immediate 8-bit. This is the 8-bit data stored into the register or memory. This is the immediate data. LDA, load the accumulator. The content of the memory location 16-bit is copied to the accumulator, that is the load. Right. Here you can see STA. STA means the content of the accumulator is copied into the memory location, that is store accumulator to a specific operand. So 3-byte instruction, the second byte specific, the low order address. And address, it is also address. So that's why here whenever you are coming to this, you can see that direct, which one is direct? This one is direct, because here it is only one memory reference. This is one. Whenever you are coming to immediate means this is MBI. I is immediate. That's why it is immediate. Now indirect, this is MOV, because you are going to that location, after that you are fetching. That's why it is indirect one. And finally the register addressing mode is this one. MOV A, B, both are register. One register to another register, you are moving the data. So this is most important, must remember. Maximum high chance is there, this type of question you can get. They are making this type of question where you need to match the addressing mode with the instruction, and that's why all 8085 instruction, 8086 instruction is very important. Now see another question. Hard disk addressing mode, pipeline, processing and IO. Now we are going to enter in another topic, next topic. Yes, here the answer is this one, because hard disk is related to seek time. We did disk scheduling algorithm. In disk scheduling algorithm we learned seek time. Right, addressing mode implied is one type of addressing mode. IO transfer, input output transfer, it is related to DMA. And pipeline processing for the speed up factor. So option B is the correct answer. Very good. Acha. Now it is a home task for you, because this question itself will take your half an hour to explain, but it is a highly most important topic of addressing mode. You can get 10 marks comprehension type question. You can get high chance. You can get comprehension type question from here. So must do this home task and must solve it, and let me know your answer in the comment section. It is very, very important for you. Must do it. High chance comprehension type question, you can get it from here. Okay, must do that. Now I am going to the next question. Here the next question is this one. Do this one. Next I will take tomorrow all the expected question, and that question whatever I gave you home task, I explained already this question previously. The explanation is there. I will give you the link. After solving, you can watch that link to get the answer. Okay, that video is already there in this channel. I will add that link in the description so that you can find out the answer. Yes. Here this is the next important topic, that is service routine. Multiple time questions are coming from here. Service routine, what is the sequence? So what is the concept here? Concept is here, I am running a program. Okay, one by one I am running. My program counter is here. I am running the current something. Now see that whenever I am executing something, some interrupt came to me. So what I will do, I will complete my current execution. After that, the next one to be executed, that address I need to store in a stack. That address will be stored into the stack. Then I will go and serve the interrupt. After serving the interrupt, again I will come back to the stack. I will pop out the next instruction to be executed. Then I will start executing here. This is the concept of interrupt service routine. Or here you can see that. That's why here what it is going on, save the content of the processor register wherever you are currently. Then check the flag set, because from where the interrupt came. Okay, this is the service. It can be interrupt, it can be anything. From where I have to go for the service. Then service device whose flag is set. Which flag is set here, I will understand. Okay, this here I have to do the service. After that, restore the content into the processor register. Then again turn the interrupt facility on. Okay, I am working. Then after that, now I am ready to take the interrupt. So this is the correct sequence. You can see again another question from this same area. Whatever I explain you, same area, same type of question. Tell me the answer. Yes. So answer is option A. Definitely, just now I explained. So that's why option A is the correct answer. Very good. Now tell me. Again, same question. Actually, this is also same question. No need to do it. Same question. Do this one. This is a numerical. The numerical is also most important. Highly chance you can get the numerical. High chance is that. Yes. So here how to do it? No. If you need break, you can go. 5 p.m. paper 1 is there. Why you are too much? You don't have that much patience, you can go, no problem. Tomorrow is an exam. So here how to do? 2048 multiply into 8, right? 2048 multiply into 8 divide by 128 multiply into 4. You have to do. So the number of chip required we can calculate from here. How it is actually, I will suggest you go for like that. 2048 means 2 to the power 10 means 1024, 2 to the power 11 means 2048. So it is 2 to the power 11 multiplied into 2 to the power 3. Then this is 2 to the power 7 multiply into 2 to the power 2 square. 2 square. Okay. So what it is? This is 2 to the power 14. And what it is? This is 2 to the power 7 plus 2, 9. So 2 to the power 14 by 2 to the power 9 means it is 2 to the power 14 minus 9. That means it is 2 to the power 5. That is 32. So answer is 32. Like this way you are doing it. Like this way if you are solving, then it will be easy. Otherwise it will be difficult. Okay? Easy calculation is like this way. Do it. Yeah. Now do the next. Thank you. Thank you. Paper 1 class is there 5 p.m. Tulasi ma'am will take the marathon. So definitely I will give you 30 at least minimum 1 hour 30-minute break minimum I will give you. Before 4:30 I will end. 5 p.m. there will be the paper 1 marathon for 100 MCQ. Tulasi ma'am will take all expected 100 MCQ. Yes, in cache memory, if the 9-bit in the tag field and 12-bit in the index field, the size of the main memory and cache memory would be what? Think and answer, everyone. Numericals are very important. You can't go away from numerical. In computer architecture, numerical is there, operating system numerical is there, networking numericals are there. You have to do. Yes, here option D is the correct answer. Most of you are telling option 3. This is not correct. Here, how to do that? Here it is given that 9-bit is the tag field and 12-bit is the index field. Okay, here cache memory is divided into 2 part. Here you are getting the main memory. Okay, main memory to cache memory. The mapping is going on. So here it is the mapping. You have the tag and you have the index. So that's why the total bit you are getting here 9 plus 12. So 9 plus 12 means 21. Total it is 9 plus 12. That's why total it is 21. Now when n bit means from here I can calculate the size, that is 2 to the power n. So it is coming 2 to the power 21. Now 2 to the power 21, you will think that how it is coming. See that 2 to the power 21 is coming. Okay, 2 to the power 21 means what? It is given answer in K. See that it is given answer in K. K means KB. K means KB means it is 2 to the power 10. So actually we can write it 2 to the power 10 multiply into 2 to the power 11. Okay, or opposite way I can write, that will be easy for you, so that it is matching with the option. It is 2 to the power 11 then 2 to the power 10. So 2 to the power 10 means what? KB. 2 to the power 11 means what? 2048. So 2048 KB. That's why it is 2048K. That's why it is 2048K. Okay. No offset is not there. It is cache. It is cache. Offset another. Next question I am coming. That is offset. There we have to calculate offset. So that's why it is 2048K. Okay. Then it is asking you the next one. So you are doing here main memory. You got the size of the main memory. Then the cache memory. So the cache memory, now we have to calculate 2 to the power index plus offset. Here we have to do index plus offset. Here index is same 12 bit, but offset is not given. Offset is not given here. So that's why, but I will do 2 to the power 12 itself. So when I am doing the 2 to the power 12, again 2 to the power 12 means what? 2 square multiply into 2 to the power 10. 2 to the power 10 means kb. So kb means again it is 4 kb. That's why your answer is coming 2048K and 4K. 4K is the cache size and this is main memory size, because here offset is not given. Here offset is not given. Right? That's why you are getting the answer like this. Got it? Clear? Yes. Now you see here. Next question. Here now you have to the cache where you have to calculate the tag, line and field, everything. Here you have to calculate everything. Offset not given, that's why we took offset 0. Actually this is the detail. Where all the part is required. 3 parts are there: tag, line and offset. Tag, line, or we can say index, and offset or size, that you need to calculate here. Yes, here you are getting answer. Definitely how to get the answer, here you can see that collect the data. Main memory is 2 to the power 16 byte block, size is 8 byte. From the 8 byte only you can calculate this is 2 to the power 3. So here directly you can see that 5 field format, last one, it is given the sequence like that. First one is tag, next one is line, next one is offset. So already offset I got it 3 bit. I can do the answer. This is not my answer, this is not my answer. Right? And here you can see that direct map 32 line. 32 line means 2 to the power 5. So 5 bit is for line. So you can see here is only 5. This is 6. So you got the answer already. No need to calculate the remaining part. Without calculating also already you got the answer. But okay, for doing the answer we can do it here. From here we know that it is total 16 bit. That's why now 16 minus 5 plus 3, that is your tag part. So tag is 8. Right? So answer is this one. Like this way we can calculate here. So total is here, from the main memory we got it total this one. So answer is there. Right? Okay. Now next one. Now do this. Again another numerical. This is all that the very important numerical of computer architecture. Do this. सेशन को लाइक कर दो भाई, सब सुनते नहीं रे, ये लोग सुनते नहीं, सबको चाहिए सेशन तो चाहिए। मैम मैराथन ले लो, मैराथन ले लो, मैराथन देखेंगे सब, लेकिन लाइक करने में कंजूस है ये लोग। मैं तो कंजूस नहीं हूँ, मैं कभी भी क्लास में आके कंजूसी नहीं करती हूँ, लेकिन लाइक करने में सब लोगों का बहुत कंजूसी है, बहुत, पता नहीं क्यों, क्या होता है। लाइक करने में पैसा भी नहीं लगता है, कुछ भी नहीं लगता है, एफोर्ट भी नहीं लगता है। मैं क्लास लेने के लिए जितना एफोर्ट देती हूँ, पता नहीं क्या होता है सबको लाइक करने में। चलो, 80 ट्रैक स्टोरिंग 128 बाइट पर सेक्टर, and this is the byte. How many sector does this disk have? Yes. So here actually what is the structure of a disk? The structure of a disk is looking like this. These are called these are the total disk, and in the disk these circles are called the track. Okay, the circles are the track, and each and every track is divided into some sector. These are called sector. Okay, so track sector is the A track is a means you can think like that. Disk is the collection of track. Okay, some track. Now track is the collection of some sector. Okay, each and every track is divided into sector. So that's why now we will do it. So here total storage is given, number of track multiply into number of sector per track, then number of byte per sector. Like that way we can calculate. So here whenever we are calculating, we don't know that how many sectors are there. That is my unknown area. Other than that, it was given. This is given, this is also given. And total structure is also given. Total is given here. Now just directly we have to calculate. Now here you will think that how to calculate. Again you will get stuck. So here no need to stuck. Here actually whenever you are doing this, it is you need to think what it is. 2 to the power 10. 2 to the power 10 is 1024. Actually if I am multiplying 16 multiply into 1024, I will get this number. Yes or no? Because it is 1, 2, 3, 4, 5, 6. So if I am multiplying 16 multiplying to 1000, I am getting 16, 1, 2, 3. So 1, 2, 3. Here I need 1, 2, 3, 4. It will be actually 160. It is actually 160. If I am doing 160 multiply into 1024, then I will get this number. 160. If I am doing 160 multiply into 1024, right? Yes, then I will get this number. Just check it, you will get it definitely, because this is 160. Yeah, then you will get it. Now after that you are getting here 80 multiply into 128. So how I will do? 160 multiply into 2 to the power 10, 80 multiply into 2 to the power 7. So I am getting here 2 to the power 3, and I am getting here 80 by 60, that is 2. So I am getting here 2 multiply 8, that is 16. So you are getting here answer 16. So in my class I know that where you will get stuck. Calculation will be difficult for you, and that's why I am showing you how to do calculation without calculator. Without calculator you can do calculation like this way, so that you can get the answer. You don't have calculator. UGC NET is not providing you calculator. So do always calculation like this way. Got it? Clear? So final answer you are getting here 16. Okay. Now do this. Now do this quickly. My daughter will come from school very quickly. IEEE, I covered that one. You can see that in the GATE playlist. In GATE playlist, I think I have covered IEEE 754. Nowadays they are not asking, but I have covered in the GATE playlist. You can check it. Yes, it is easy. Definitely combinational and the sequential circuit, you are getting option A and D is the correct answer, because output of the combinational circuit depending only on the current input. That is correct. Combinational circuit depend on both current and previous, not at all. Here output of the sequential circuit depends on the current, not. Sequential circuit depends on both current and previous. Alright. Here you tell me. This is, do this. Which of the following are the sequential circuit? Yes. So definitely A and C, because flip-flop and the counter is sequential circuit. Now tell me, which one is storing 1 bit data? Storing 1 bit data. Yes, definitely flip-flop is storing 1 bit data. So here you can see the difference between combinational and sequential circuit. Combinational circuit means there is no feedback. It is not coming directly doing. Combinational circuit, do not depends upon the previous input and generate any output in terms of the combinational circuit itself. And sequential circuit depends on the clock cycle and depend on the present as well as the past input. So combinational circuits are encoder, decoder, multiplexer, demultiplexer. Sequential circuit, flip-flop and counter. Very, very important. You are getting question multiple times from this area. Just now we did these two questions. These are the questions from where you are getting this type of question, right? So please remember it. Now see. Now do this one. Now again another question from this topic. Tell me the answer in the comment section quickly. Quickly tell me the answer. Just now you get the combinational circuit and sequential circuit. What is the answer? Let me know in the comment section quickly. Yes, here this is your answer. Output at a time, input of the function, and do not have feedback. This is your correct answer. Now the next topic. Do it. Good. IO protection, IO interrupt. Yes. So here your answer is IO protection ensured by the hardware trap. This is wrong. IO interrupt caused by this is true. Why it is? You can read here. You can read quickly. Read it so that you can understand it. Yes. So I hope you understand that why it is not correct. So this is the correct answer. Now tell me. Now do that. The IO method that allow the memory address and the IO in address distinct. It is distinct. Is called what? Yes, this is isolated and memory mapped. Isolated and memory map. Okay, option 1 is the correct answer. Why it is? I am telling you. Why? See that isolated and memory map, very, very important. Isolated IO. Isolated IO. We have the isolated. You can see the image. By looking the image, you can understand here. This is the memory and this is input output. So input output is address bus and data bus. They are not common, right? Here you can see they are separated with each other. So that's why here we have the common bus, although they are doing separate, but they are using the common bus. They are using the common bus. So for IO memory, but separate read-write memory. Here separate same bus they are using, but the separate read and write control line for the input output. So when CPU decode the instruction, then if the input output, then place the address on the address line and set IO read or write controller line due to the data transfer. This is isolated IO. And whenever you are coming to memory mapped IO, you can see here it is common. They are sharing the same space. Memory and input output sharing the same space. So in this case, the bus common due to which have the same set of instruction, no different set of instruction, work for the memory and input output. Hence, we manipulate IO same as the memory, both have the same address space, due to which the address capability of the memory become less because some of the part is occupied by the IO. This is called memory mapped IO and this is called isolated IO. Very important difference. Just see the difference with the image, it will be very clear. Just see the difference here. They have different space, memory and IO, but they are sharing same. But here whenever we are coming to the memory map, then they are using the same and this address and bus and control is also same. This is the difference. And here you can see quickly the isolated IO and memory map IO difference between them. Just quickly read it, and it is most important from where you are getting multiple question, the difference between isolated IO and memory mapped IO. Okay? Yeah. So now the next question you can see again, technique of performing IO operation. Yes. So here option 2 is the correct answer. Definitely here these all are we learned just now. Programmed IO is also there, interrupt IO is also there, and direct memory is also there. So channelized IO is also there. It is also one of the part. The correct answer should be actually A, B, D and E. E is also coming, but the option is not there. So we are choosing the best, most preferable answer, this one. It could be the IO channel, but less commonly used. My IO processor IO channel is less commonly used, and that's why we are choosing here ABD. Okay, but ABD all are correct. Now see, now do the matching here. Handshaking, programmed IO, interrupt IO and IO processor. Yes, here your answer is this one. Definitely option C is the correct answer. Very good. Here you can see programmed IO and interrupt IO. What is the difference? Just quickly read it. Read it quickly. I am coming in 1 minute. Yes. I hope you understand the difference between programmed I/O and interrupt I/O. Yes. Now do the next. Here it is most important topic, DMA. From where you are getting multiple question multiple time. DMA is the most important topic. Very, very important topic. DMA transfer, different mode of DMA transfer actually most important. And here the sequence question is there. Do it quickly. My daughter already came. But I will continue. I will complete it. After this topic there is pipeline and programming, means some instructions are there. We will do it. Quickly do this. Yes, here the answer is this one. The first sequence, initiate the DMA. First of all, initiate it. Then processor grant the DMA. Then after that, transfer the data. Then finally, data controller. So it is this one. Alright. Yeah. Now see here. When using the multi-cycle micro operation, which type of memory transfer most preferable? The meaning is most preferable to cause the cycle to be wasted. Which is causing, preferable means not susceptible, which is it is not preferable, it is susceptible. So which one most susceptible means why the problem is happening. Yes, why the problem is happening. Here the answer is burst most transfer. Very good. Next question, I will tell you the reason and revise will be done. Next question, again you can see the DMA transfer mode, entire block of the data transfer in one contiguous sequence. Which DMA? One contiguous sequence. Yes, that is again burst mode. Here this is also burst mode, this is also burst mode. Now here the method of the DMA, that transfer involving moving one word data at a time. One word data at a time. Yes, this is cycle stealing. Right, now you can see here, this is the DMA. Quick revision we can do. DMA basically stands for direct access memory, where it is a DMA controller, and here is the CPU and here is the memory. Directly here between memory and this one, transfer is going on. Okay, so which enable data transfer between memory and I/O input output devices. Here this memory and input output devices will transfer the data without involvement of this CPU during this data transfer. How it is possible? Here how this DMA is working. The DMA basically is a hardware which is controlled by this. First I/O device send the DMA request. Okay, now it is accepting the request, it is holding the request, then CPU then share two basic information to the controller before transferring. Sharing the address, that memory address starting from where it can start, and the data count, that how much data I have to transfer. Then CPU then send the hold acknowledgement and back to the DMA that yes, I am acknowledging it, you can do it. So now DMA can successfully pass the information. Then DMA means controller share the acknowledgement to the input output device, which would be now input output device will start it. This is the way how DMA is working. Okay, so here you can see that there are first mode is called burst mode. Burst mode means this burst mode entire data. With the name only you can understand the entire data, total block I will send together. That's why it's need more time. Okay, so that's why here it is fastest mode of DMA, but less user friendly. During the DMA transfer CPU is blocked here, and that's why the percentage of CPU block time is 100% here. From here also that questions are coming. Percentage of block CPU time is totally 100. Total time CPU is idle when DMA is transferring huge amount of data. Whenever you are coming to the cycle stealing, it is preferably better one, because why? Here IO device, slow IO device makes some time to prepare the data, right? Okay, I am preparing. At that time CPU can do work. Within CPU keep control to the bus. Once data or word is ready, CPU give back that to the DMA and it is transferring. So DMAC is getting a one cycle which prepared word. At that time CPU is sending, that is the cycle stealing. Means throughout the time CPU is not idle. So it is most efficient way of DMA transfer, and CPU also won't get blocked entire time. That is a good thing. So that's why rate of the DMA transfer will be less. Percentage of the CPU remain blocked, it will be little bit lesser than the burst mode. Now interleaving mode. Whenever CPU does not require the system bus, then only the control bus will be given to DMAC. So always here priority to the CPU. CPU is doing work, then DMA will not get chance. When CPU don't have any work, then only DMA will get the chance. So CPU will not block due to the DMA at all. Here the percentage of CPU remain blocked 0%. DMA will use the system bus, only CPU is not using. These are the three modes of DFA, which is very important. Got it? I hope it is clear. Interleaving mode, cycle stealing mode and the burst mode. Very very important. You are getting multiple questions from here. Nowadays it is very common. Okay. Now do this. Here you can see now increasing order of the complexity. Do it quickly. Can I get the attendance who are present now? I can see 60 learners, but all are hiding. I can see only Rajita, Priyam, Nishu, Muthu Kumar, Manasmita, Ranjita. They are only answering. Manikant. What about others? All others are silent. Whenever I told 60, then 5 get down. All silent learner don't want to show me that yes, I am watching your class. I am your silent learner. They don't want to show that. Mohana, Manikanta, Priyam, Nishu. Okay, I am getting answer. Very good. Here you can see the increasing order. Always remember that increasing order means where more complex, that is processor. Whenever you are processing something, then it is more complex. That's why processor is the complex one. Then it is coming to the channel. So processor and channel almost doing the same thing, so that's why channel. Then next one is DMA and finally module, because module is the IO input output module only. Right? Yes, you read it, I am calling your name. Sandhya, Leah Santosh. Another name I am not able to read. Neelam, Parameshwari, Rajita, Nitesh, Archana, Bhavana, Muthu Kumar. Achha. All are silent. See that. Then only whenever I told 60, then now it is 48. So 12 learner already cut down. No. अरे मेरे नाम ले लिया तो क्या होगा? मेरा नाम नहीं लेना है ना? How is this? Means if I am taking your name, what will happen? कि कोई घर पे आ जाएगा क्या? अरे भाई चलो उठा लो इसको, ऐसा होगा क्या? If I am calling your name, if you are showing that okay, you are YouTube class, you are watching YouTube class, and your name means they will not understand also, right? They will go to your house and they will just उठा लो ऐसे होगा क्या? This question just now we solve it. This is also we did. Do this one. Cache coherence. This is also very important topic. What is cache coherence? What is cache coherence? Answer quickly. Yes. So here allow only the non-shared data and allow the snappy cache. What is this cache coherence? The cache coherence is the thing in the multiprocessor system. Data inconsistency may occur among the adjacent level with the same level of memory hierarchy. Actually, from the main memory, there are different cache. You are storing here also, you are storing here also, you are storing here also, right? Now here what is happening? The shared memory multiprocessor with the separate cache memory, each processor. It is possible that have many copies of any one instruction. Maybe here the variable a equals to 10. First time I am storing here 10, here also I am storing 10, here also I am storing 10. It is okay. Now one copy of the main memory and one each in the cache memory. Now when one copy of an operand is changed, maybe here I changed to 20. Okay. Now other copy of the operand must be changed also. As here it is changed, now here and here also it need to be changed. But if it is not changed, then it will create the problem. So the cache coherence is typically the address to the implementation of cache coherence protocol. This is the problem. This protocol defines the rule or the mechanism for managing the data access and ensuring that all cache in the multiprocessor system have consistent copies in the shared memory. If you are updating one side, another you are not updating. Maybe it is updated here, but these caches are not updated. So it will create the problem. So this problem you have to avoid through the cache coherence. Here are some common approaches for this solving cache coherence problem. Snooping based protocol, directory based protocol, snarfing, invalidation based protocol, update based protocol and coherent cache. Okay, this is the concept of cache coherence. Now you can see another question. In the context of multi-core processor, and just now we did it, that is coherence, right? So here you see that this is the example of cache coherence. Here it is little bit, sometimes these questions are coming. MSI protocol, modified shared invalid. MOSI protocol, modified owned shared invalid. MESI, modified exclusive shared invalid. MOESI, modified owned exclusive shared invalid. These are the cache coherence protocol in the multiprocessor system. Okay, very important. Sometimes they are asking question from here also. Now do this one. The method used to prioritize the multiple interrupt is called what? Yes, this is called daisy chaining. Prioritizing the multiple interrupt is daisy chaining. Okay. So here you can see that here is the interrupt and pooling. Pooling means pooling is not the hardware mechanism, it is the protocol. For steadily check that whether the device need attention. This is called pooling. Okay. And interrupt means interrupt is the hardware mechanism. The device noticed that the CPU that required attention. This is interrupt. And here whenever this is the difference between interrupt and pooling. Maybe you will be confused. So interrupt is not a protocol. It is a hardware mechanism. Whereas the pooling is a protocol. Interrupt device service interrupt handler. Pooling the device serviced by the CPU. Interrupt can take place anytime, but CPU steadily regular interval, with the regular interval it is checking it in a software way. Because just like a program in a regular interval it is checking. Is there any problem? Is it required any attention? Like that. while pooling command ready bit is used for indicating that the device requires servicing, and in interrupt request line is used for indicating that it's required servicing. That is the difference between interrupt and pooling. Okay, and here is the priority interrupt, software pooling, or the daisy chaining. This is called. So priority among all devices are for the systematic one. This is called daisy chaining. That's why here your answer, this is the daisy chaining method. From here the question came. That's why here you can see the answer is method of prioritizing the multiple interrupt is daisy chaining here. The daisy chaining is the method involved connecting all the devices that can request an interrupt in a serial manner. This configuration governed by the priority of the devices. The device with the highest priority is placed in the first, following the second, and then next. This is the daisy chaining method. Okay. Now see, another question is here. Yes, here your answer is again daisy chain. Daisy chain is the correct answer. Very good. Now here locality of reference. This topic is also very important. What is locality of reference and the cache operation? Locality of reference refer to the phenomena which the computer program tends to access the same set of memory location in a particular time. In other words, the locality of reference refer to the tendency of the computer program to access the instruction whose address are near to another one. Okay, near one another. So, this property of locality reference is mainly shown by loop and the subrouting calls of the program. Locality reference, so many times questions are coming from locality reference also. So remember that this is locality reference. Here you can see that. With this diagram you can understand the locality reference concept. Okay? Yes. Now you can see next question from RISC and CISC, which is next important topic. Yes, temporal and spatial locality of reference. Two types of locality of reference are there. RISC and CISC, next important topic, very important, do it quickly. I have to end the class because paper 1 class already scheduled at 5 p.m. Yes, here your answer is this one, definitely correct answer. Why it is, I am telling you. RISC means reduced instruction set. The main idea behind to make the hardware simpler by using the instruction set composed of the few basic steps, that is loading, evaluating and storing operation. Just like the load command into the load data, store command will store the data. And here the complex instruction set CISC, the main idea, a single instruction will do all loading, evaluating and storing operation. In one instruction you are trying to do everything. Just like a multiplication command will do stuff like loading data, evaluating data, storing it. Hence it is complex. Both approaches try to increase the CPU performance in different way. So here you can see the difference. RISC focus on hardware, CISC software, CISC focus on hardware. So RISC is hardware control and CISC microprogram control. Transistors are used more, registers here. Transistors are used more, complex instruction here. Fixed size instruction, it is variable size, can perform only register to register arithmetic in RISC, and in CISC register to register, register to memory, memory to memory, everything can be happen. Required more number of register here in RISC, CISC less number of register. Code size is large in RISC, CISC code size is small. And instruction execute in single clock cycle. Instruction takes more than one clock cycle. Okay. So it is the difference between CISC and RISC. Now you can see here the question again on CISC and RISC. Just now I show you the difference. So now tell me the answer. Very important topic, CISC, RISC. Yes. Here CISC computer have large number of addressing mode. It is also true. RISC instruction access limited to load and store. It is also true. So these both are true here. Right? Just now we did it. Now tell me. Arrange the following machine descending order as per the complexity. Easy question. Descending order as per the complexity. Yes, simple. SISD means single instruction, single data. That is the simplest one. Then single instruction, multiple data. That is the middle one. Multiple instruction, multiple data is the highest one. So this is your answer. Yeah. Now you have to match. Here these are the most important instructions of 8085 from where they are making question. SZA, SKI, SNA, ISZ. Yes. Here your answer is this one. Why it is, you can see here, these are the instruction set. You can go through it. You can take the screenshot, which is very important. Here ISZ is increment and skip if 0. Other than that, all other instructions are very important for you. Next instruction you can see here SNA, skip next if accumulator less than 0. Not only this one, other related instructions are also important. You have to learn all the related topic. From one question, if you are learning related topic, then only there is the meaning of doing PYQs. PYQs means, okay, I will know the answer and I don't know the related topic. There is no meaning. From the question, only these 4 means the related, all these instructions are important for you. This all instruction must revise, which is most important instruction for you. You can get again question. Okay. Now you can see here, now we are entering to pipeline. After doing pipeline, I will end the class. Pipeline theory and pipeline numerical is also very important. Here you can see the statement regarding K segment pipeline. Which one is true? Yes. Here the maximum speed up can be divided into K theoretically. It is impossible to achieve actually K segment pipeline because there will be some problem. What problem? With the numerical you can understand that. So this one is true. This is false. Correct. Now you can see here the numerical. Read the numerical and do the answer. 5 stage pipelines are there. These are the actually 5 stages: fetch, decode, execute, memory and write back. Each stage takes 1 clock cycle to complete. Assume that no pipeline stalls and the pipeline is initially empty. So how many clock cycle required to complete the execution in 10 instruction? Of 10 instruction. Very easy, very simple question. If you know the formula, then easily you can do the answer. Quick, very easy question. Yes, here answer is 14. K plus n minus 1. Number of cycle in the pipeline K plus n minus 1. K is the number of stages. K is number of stage, that is 5. N is number of instruction, this is n. So answer is 14 directly. Now see another question. This type of question is also very popular, where you need to determine the speed up ratio. Speed up ratio. Yes, here the answer is 4.95. What is the formula for speed up ratio? Formula for speed up ratio is this one. NTN divide by N plus, that is non-pipeline. You have to do non-pipeline by pipeline. So for non-pipeline this is NTN, and pipeline it is N plus K minus 1 then TP. So whenever you are calculating, now in the calculation you will get stuck. You will get stuck. 500 multiply into 50 divide by, here it is 500 plus 5. It is 500 plus 5 means it is 505 multiply into 10. Now you will see it is 5. And now you have to think easily. 500 by 500 is 1. But it is actually 500 divided by 505. Means my answer will be less than 1. So my answer will be less than 5. Close to 5 but less than 5. So close to 5 but less than 5. Very close, because it is instead of 500 by 500 it is 505. It is very close to 1. So if I am thinking as 500, it will be 5 multiply 1 5. But it is very close to 5. So go to the option, you will get the answer. This is not. This is greater than 5. This is also greater than 5. Definitely this is your answer. Don't waste your time to get the accurate result. It's not required accurate result. Whenever you are solving it, don't try to waste your time. No need to try to waste your time. Directly you can do the answer. Right? Yes. So answer is this one. Now another question. Quickly do this. Here a multiprocessor system with 16 processor execute the parallelizable task. If the serial portion of the task takes 200 clock cycle, parallel portion takes 800 clock cycle. When all the 16 processor are used, how many total clock cycle are required to complete the task? If large number instruction given, then it will be Tn by Tp exactly. Yes, here answer is 250. 250 is the correct answer. How to do it? Here you can see that 200 clock cycle given. So clock cycle per processor, parallel portion, but number of processor. So it is 800 by 60. You are getting 50 clock cycle. Total clock cycle will be serial portion plus parallel portion. So serial portion directly you can do 200, and parallel portion I have calculated 50. So it is 250. Okay, that's why you are getting here 250 like that. So your answer is coming 250, because serial will be same. Here in the question you can see already 200 clock cycle for the parallel and 800 clock cycle all 16 processor. So like this way we are getting the answer directly. It is 250. Now another question. I think it is the last one. It is the last question for pipeline. This is another type of pipeline question. Consider an unpipelined machine with 10 nanosecond clock cycle. Use 4 clock cycle ALU operation and branches where 5 cycle of memory operation. Assume that the relative frequencies 40%, 20%, 40% respectively. Due to clock skew and the setup pipeline, let us consider this. Add 1 nanosecond overhead to the clock. How much speed up is observed in the instruction execution rate when the pipeline machine is considered? Yes, your answer is 4 times here. How you are getting 4 times? You just mark the all important data. Average clock cycle it was given, see that. So from here we can calculate 4 multiply into 0.4. It is point is there, okay. Here 0.4. Then 4 multiply 0.2, you are getting this 4.4. And without pipeline it is directly we will go do 10. And with pipeline we are getting some overhead, that's why 10 plus 11, 10 plus 1, that is 11. So speed up will be 44 by 11, that is 4 times. So finally you are getting answer here 4 times. With this one my class is end. So all types of question, those who are watching till now, you understand that from basic till advanced everything I have covered here in one class. I hope you will like this class. So please like and comment me in the comment section what you need for tomorrow. Last class, 26th is your exam. What you need for tomorrow? Okay, what do you need? Just give me idea what is your expectation from me tomorrow, how I can help you at the last moment. Okay, chalo. Bye everyone. See you again tomorrow. Let me know that what you expect in comment section after ending the class. Thank you. Thank you. Bye.